This video is going to be for September 7th, September 8th. What we're really looking at here is what's going to happen if we take our parent function, either cosine or sine, and multiply x by a value. You're going to need to go to this link to play around with what's happening in terms of the function change if you really want to see it. I'm going to summarize here and then show one more piece on the back. We didn't get too much practice on these days, but I think we saw the actual concept, which is the key. And what we noticed here is, we noticed that if we multiply x by a number, the function, and I still, again, recommend going to Desmos. The link is on the website as well. It's actually, if the period was 2 pi, what's happening is, if I multiply x by a value 2, it's actually shrinking the period. So for example, if we have f of x equals cosine x, that function's period is 2 pi. That's the parent function. So its function period is 2 pi. But when we multiply x by 2, again, using Desmos, you can use that slider, move it to 2. What we saw is the period became pi. And so what we try to do here is take a look and think, what is changing? The period is changing, and the number that x is being multiplied is changing. So here, x is a 1, here we're multiplying by 2. So that has to affect the period. Excuse me. What we talked about is, if our original period is 2 pi, we multiplied x by 2. If we divide 2 pi by 2, then that 2 pi divided by 2 would be pi, which gave us our period. So that was what we thought. That's what our hypothesis was. And so we checked it. So if it was cosine, again, of 2x, then our period, we took 2 pi divided by 2, and that gave us pi. Same thing here. But we hypothesized what would happen if it was cosine of 4x. And we got a lot of different responses, but and again, highly recommend going to Desmos so you can actually see it. It's really, I think, powerful for you to see it. We could take 2 pi, our original parent function period, and because x is being multiplied by 4, we can divide that by 4. And if we do that, then we would get 2 pi over 4, which simplifies to pi over 2. So this is what we did at the beginning. We noticed what's happening as I move that value that's multiplied by x. If it gets larger, we notice if I multiply the number by x, number 2 and 4, as it gets larger, the period is actually getting smaller. Here it's 2x, the period is 2. Here it's 4x, the period is pi over 2. So it's getting smaller. Then we started looking at, what about if it's x over 2? What if it's x over 2 like here? Well, again, we know that the period of cosine x is 2 pi. And it turned out, what we noticed, and again, highly recommend using Desmos because that's a lot what we did in class. It turns out that the period of this guy is 4 pi. So we said, what's happening here? Well, we can take our parent function period, similar to what we did here, starting off with 2 pi because that's our parent function period. And students, what they thought is, here, I'm dividing by 2. Here, I was multiplying by 2, so I can divide by 2 here. Here, we were multiplying by 4, so I can divide by 4 here. I'm going to skip this for a second. So if I'm dividing by 2, then that means I can do the reverse and multiply by 2 to get 4 pi. And let me do this because we're going to have to come back here. Now I'm leaving a space here so we can come back to that so I can hopefully make a point at the end here. If you need to pause, rewind, ask questions in the middle of it, please do so. Please, please, please. So then I said, okay, good. I think we're seeing something. We noticed some kind of pattern. But what if it's cosine of x over 3? Well, students said, okay, then the period, because x is being multiplied or divided by something, then we know that that's going to change the period. We can start with 2 pi because that's our parent function period. I'm going to skip again. But because we're dividing by 3 here, we would multiply by 3 there to get 6 pi. Because whatever's happening to x is being divided by 3, which means I'll take the period similar to what we did here, multiply by 3 to get 6 pi. Okay? Seems to make sense. But then students really had a hard time here because here it looks like x is being multiplied by a number and divided by a number. And so students were like, I don't know what to do here. And what I push students to think about is x here is being multiplied by a number. What is x being multiplied? A lot of students said 2. And that's true, but what about this 3 there? And what's really happening is x is being multiplied by 2 over 3. If I have this little side note, if I have x over 1 and I multiply by 2 over 3, I get 2x over 3, which is here. So x is really being multiplied by 2 over 3. And because x is being multiplied by 2 over 3, then we kind of go back, I'm going to scroll up, back to these cases. X was being multiplied by 2, so we divide by 2. X is being multiplied by 4, so we divide by 4. And so once I was able to separate it, students said, okay, then the period is going to equal 2 pi. Again, that's our start because that's our parent function period. That's the period of our parent function cosine. And because x is being multiplied by 2/3, similar to what's happening up here, multiplied by 2, multiplied by 4, then we would divide by 2/3. And then we would take that, if we know hopefully that if we're multiplying by or dividing by a fraction, we must multiply by the reciprocal. Simplify from there, and our period becomes 3 pi. And this is the key idea. Every single time x is being multiplied by a value, doesn't matter what that value is, you would take the parent function period, in this case would be 2 pi, and divide by that value. Now I left some blanks, where was it? Here and here. And the reason I did that is we can also think about here, x being multiplied by a number. It is being divided by 2, it's also being multiplied by 1/2. And because x is being multiplied by 1/2, what we can think about is, since x is being multiplied by 1/2, we could take our parent function period 2 pi and divide by 1/2. Parent function period 2 pi, x is being multiplied by 1/2, which means we would divide by 1/2. If we're dividing by a fraction, we're multiplying by the reciprocal. The reciprocal of 1/2 is just 2, and so that's what happens here. Similar thing here. X is being divided by 3, but it's also being multiplied by 1/3. So because x is being multiplied by 1/3 here, we would take 2 pi and divide by 1/3. If we're dividing by 1/3, we're also multiplying by the reciprocal. The reciprocal of 1/3 would be 3 over 1, or just 3, and so we get to 6 pi. So what we're saying here is no matter what x is being multiplied by, x is being multiplied by 2. Parent function period is 2 pi, divide that by 2. 2 pi divided by 4. Here, 2 pi divided by 1/2, which is the same thing as multiplying by 2. Here, x is being multiplied by 1/3, 2 pi divided by 1/3, which is the same thing as multiplying by 3. In general, if you have questions, pause, rewind. You can always ask me as well. Anytime x is being multiplied by a value, I'm going to call that value a. If it's sine or cosine, here we saw all cosine, but the period for the parent function cosine is 2 pi. The period for the parent function sine is 2 pi. So we would take our period, 2 pi, does not matter what x is being multiplied by. 1/2, 2/3, 4, 5, it doesn't matter. You're going to take 2 pi and divide by that value. That is the transformation if x is being multiplied by a value. Now in the next video we're going to see a little other change as well. What if we multiply and add or subtract inside? What do we think will happen? And we'll go through that in the next video.